All right, more decomposition practice here today, so we'll finish our lesson here. We did some questions from number 15 using the intuition method, or kind of like mental math trial and error. And we understand that when we factor a trinomial, if it's factorable, we're going to have two binomials, right? And so the first terms have to multiply to the first term in the trinomial. The last terms here have to multiply to the last term in the trinomial. And this is, again, why it's important to write in descending order of the variable. That is, if there's a squared variable term, you should write that one first, and then just a regular old variable term, write that second, and a constant should be last. So if you write it that way, then it's a little bit easier to factor, and it's always kind of the same. So we talked about how to do this by intuition. Then we talked about factoring by decomposition. And at the end here, I realized that just before, I kind of got stopped by the bell, but when factoring, we do have to make sure that we have greatest common factors pulled out, which we didn't focus on that at the beginning, which we probably should have. It's fine, I didn't want to mess up with that, but we should have pulled the 3 out of this one at the end anyways when we did this. So just to round off the lesson from yesterday, if I had time, I probably would have seen this, but we kind of got choked off at the end there. This is not the fully factored answer, because if you notice, we have a common factor within a binomial variable, so we do have to pull out a common factor whenever we can. So you see we have a 3 as a common factor here. So this is actually times 3 times x minus 2 when I split this thing up. So the fully factored version of this question that we did last day would look like this. Because we take a 3 out. This would be 2x minus 1. 2x minus 1 is what I should have put there. Okay, so 2x minus 1. This divided by 3 is 2x. This divided by 3 is 1. Sorry, what?
What would be in front of the first term?
Okay, okay. So let me talk about that. Why did I just put the 3 here right now? Is that what you're saying? So normally, if there's a constant factor, it's listed first. Because this is multiplication, it doesn't matter which one you do first or the order of them. The order doesn't matter. If you multiply 2 times 1 times 1, it doesn't matter if you multiply 1 times 1 times 2. You know what I mean? Yeah, multiplication is commutative. Go back and forth. It doesn't matter. Okay, so that's just a little bit of kind of review from yesterday. I was going to do this example right here, but I want to skip to doing number 15 because we know what some of these already are because we did them by intuition, right? So so what was that one again? Let's just write that above. So the factored version of a that we already had here was what? 5a and a. And then we need to get to negative 7. So if we had a 10a and a 3a, that could give us to a 7. And if it was a negative 10 and a plus 3a, that would give us to negative 7a. So this is the factored form for letter A. And that's how we did it by intuition. Now let's do it by decomposition. So let's refresh our decomposition here. So what we do, again, we're looking at this as the question, letter A. I multiply 5 times negative 6 to get negative 30. Now that number is the number we're going to focus on for decomposing the middle term, which is where the decomposition method comes from. We're going to decompose or break up the middle term. So what are the factors of negative 30 that add up to negative 7? Can you think of any? Well, what about 5 and 6? Let's make 1 negative. Does that add up to negative 7? No, that adds up to negative 1, right? That's no good. Oh, 10 and 3. Ooh, I like 10 and 3. That gets me to 7, you see? 10 and 3 gets me to 7. Could I get to negative 7? Yeah. Negative 10 plus 3. See that? So this is the combination of numbers that you want to use to decompose the middle term. So now you rewrite the trinomial like this, 5a squared. And then you can, doesn't matter the order really, minus 10a plus 3a. See, that's how we decompose the middle term there. And then minus 6. So I'm rewriting this trinomial with the middle term split up. And remember, that's kind of the middle step in expanding, right? Remember that? So we are literally working backwards step by step now. So decomposition helps us to work backwards step by step. So this part, again, this part is a little bit funny. You just group the first two terms and you group the second two terms, and then you pull a greatest common factor out from them. So I see a 5a I can pull out here. 5a, what's that? A minus 2? Is that about right? Okay. Is that what's left over? So 5a times a is 5a squared. 5a times negative 2 is negative 10a. This one, you're going to pull out a common factor of, looks like maybe 3. So if it's a positive 3, you want to write a positive 3 there. This is the awkward part. You have to write this as a plus 3 if that's your common factor. And then what's left over is a minus 2. Okay? So when you split this up, you get this. When you split this one up, you get this. Okay, question? Question? All right. So what we want to notice here is that the common factor between these, like this is like one giant term now, and this is one giant term. Okay, there's only one split of an addition here, right? So we have one giant term that's already factored, and then one giant term that's already factored. And if you have a common factor binomial, then you're doing this correctly. If these are different at all, if one was an a plus 2 and one was an a minus 2, then it's not working. You have to go back and maybe pull up, check your common factor, check to see how you split the middle term. So these always should be the same if you're doing decomposition method right. So if they're the same, then pull out that common factor. And then when you've pulled out the common factor, you think about dividing this big giant term by this factor that's gone, and then you're left with 5a. And when this one's gone, you're left with plus 3. And that's how you factor by decomposition. Take a moment to let that sink in, and then let me know if you have questions about that. Because remember, this is your GCF right here, a minus 2. That's your GCF. And here it is right here. And what's left over is 5a, and then plus 3 when you take those out. Can you what, sorry?
So for the a minus 2, you can like divide it out.
You're dividing the a minus 2 out of this middle expression, yeah, because it's a common factor, yeah.
Okay.
Yeah. Okay, let's do another one. We've got more here, so I'm going to erase this one now. And let's do b, okay? So if we focus on b now, I'm going to multiply 3 times negative 10. Wait, that looks like, did I just do this one? Oh, I guess we did it before. Whatever. Weird, okay. Negative 30. Did I just do this one?
I think you did.
Or maybe I just talked about it up here? Did I just talk about it up here, right? Okay. Okay. So we haven't done a decomposition. Okay, fine. So negative 30. Does everybody see that? 3 times negative 10. So what are the factors of negative 30 that get us to negative 13? Okay. No. Somebody said minus 10 and minus 3. Those are not factors of negative 30. Those are factors of positive 30. So that's a tricky one. Okay, negative 10 and positive 3, that gets us to negative 7. So this is the tricky one. Can anyone see if there's any other factors that get us to negative 13? Because there is.
Negative 15.
Yep. Go ahead.
15 and 2.
Okay, 15 and 2 gives us 30. So negative 15 and positive 2, because they have to be opposite signs, right? That gets us to negative 13. Excellent. So these are the ones that we want to split this middle term up into. So 3y squared minus 15y plus 2y minus 10. So that negative 13y has been split up with these two. Everyone see that? No?
No, not quite.
3 times negative 10 is negative 30. What are the factors of negative 30 that add up to negative 13? And that is these ones. Okay? All right? It's okay. Practice. You have to do this 20 or 30 times before you get comfortable with it. So we've split the middle term up. Now we're just grouping them. We're grouping the first two terms and the last two terms, pulling out a common factor. So the greatest common factor here is going to be 3y. So this is going to be y minus 5. Does that look good? And the greatest common factor here looks like to be 2. So I don't know if I'm going to pull out negative 2 or positive 2. Let's say you decide to pull out negative 2, guys. Okay, you could do that. Then what's going to happen is this is going to be a negative y minus 5. You see that? When you take a negative 2 out, or y negative 2, sorry, plus 5. So this is an example where, hey, I do not have a common factor. You see that? Because these are different. So then you have to go back and say, hey, is there a way I can take out another factor that would get me a common factor here? And then you would say to yourself, yes, actually, if I took out a positive 2, that would make this a positive y and then a negative 5, and now they're the same. You see? So sometimes it's like, I don't know, do I pull out a positive or a negative? That's how you know. You make sure that these are the same. Question? Yep.
Yeah, so does it mean that we have to multiply like the first number and then the third number like you did for B? If you did 10 times?
Okay, so are you talking about back at the beginning here?
Yeah, when you said
Yep, you have to multiply these two numbers to get this number, and that's the one that you have to find the factors for that add up to the middle term. It used to be that we just look at this number. What are the factors of this number that add up to this one? But now we have this pesky number in front here that it is involved in the FOIL, you see? So yeah, so we have to do this multiplication of the first number times the last number in order to split this up. And it's a little more complicated process because if this number is not 1, then we have, that's part of all of the, like a bunch of those steps of FOIL, which affects our middle term and our last term. So now we're almost done. So finally I'm going to take the common factor of y minus 5 out, and then what's left over when this is gone and divided out, I'm left with 3y plus 2. Done. And it doesn't matter which order you write those factors in. It could be, it doesn't matter. Okay? Now is this what we got before? Is this what we got before? Yeah. Shall we check? I don't have it written down here. Fine. It is good. Okay. Awesome. All right. Okay, to move on to the next one.
Was that decomposition?
Yeah. Was this decomposition? This is decomposition. You guys didn't know we were doing decomposition? Okay. Decomposition. Yeah, we're doing decomposition.
Decomposition is a choice, right?
Decomposition is choice. No, you're born that way. you're born doing decomposition. No, yes, it's a choice. Yes, but you have to know. But you have to be able to do it on the test. So you cannot choose not to ever do it ever. You have to be able to do it. But when you're factoring, okay, most of the time, if you're just asked to factor this, then you can do decomposition or you can do intuition. But because decomposition is something that is in the curriculum you have to learn, I'm going to be testing you on it. So yes, you have to know how to do this. Okay? Let's do some more. Okay, what about C? All right, 5 times negative 4 is negative 20. What are the factors of negative 20 that get us to positive 19? That should be pretty easy. 20 and negative 1 gives us to positive 19. You see that? So 5c squared plus 20, what's c? What? S. S, this is S question. Plus 20s minus s minus 4. So again, I'm splitting 19s into 20 minus 1. You see that? All right, so now I'm grouping the first two terms. Oh, trying to get rid of that, but my computer is not liking me. It's going to crash possibly here. Okay, so now I'm going to factor a 5s out of here. I'm left with s plus, looks like 4. Does that make sense? 5s times 4 is 20s. So when you pull a common factor out, okay guys, watch this. Sometimes this helps, okay? When I pull a common factor out, I'm saying that this term right here can actually be rewritten as 5s times s, right? Sorry, this is s. And then this term can be written as 5s times 4. You see that? So that we have a common factor of 5s in both of these terms. Now, when you pull a factor out, that's the wording that I use for removing the greatest common factor, so that you really, in essence, you're dividing each term by 5s. You're writing 5s as a separate factor, and when you divide that 5s out of each term, I'm left with now s here. And then I'm left over here, when these divide out, I'm left with 4. So going from here to here is sort of what we worked on in a previous lesson, but if you're still unfamiliar with that, if you're still having trouble with this, okay, factoring a expression, okay, you're going to need to get good at that. But here's a little explanation of how that works and why that works. So does that help? Everyone in here? Is there still any further questions about that? Okay. So something like this, you're going to have to recognize what the common factor is and pull it out in a sense of writing the common factor times whatever the factors are that are left over from each term. Okay, so I'll leave that up there. Let's do the next one. I'm looking at negative s minus 4. You see that? So I see that there's a negative 1 common factor in both of those terms. So that's what I'm going to pull out. Minus 1. Which gives me, when I divide the negative 1 out of negative s, I get positive s. And when I divide the negative 1 out of minus 4, I get plus 4. You see, I'm pulling the common factor of negative 1 out. Is this math making sense now? A little bit? Maybe a little bit more? Okay. Okay, pause. If going from here to here troubles you, you need to come talk to me after class. Okay? I have many, many practice questions for you. You will need to practice this. Okay? You need to get better at this. If this gives you trouble at this level, you need to practice it some more, and I can help you with that. So come talk to me at lunch. Let me see, what day is today? Yeah, you can come talk to me at lunch, after 12:30. Okay? But come talk to me. I would love to help you get better at this, because that's really important. If you suck at this, then you're going to suck at all of this. Okay? And I don't want you to suck at anything in math. Okay? I want you to be awesome. Okay, so I pull this common factor out. What's the common factor? S plus 4. It's in both terms. S plus 4. What am I left with when I divide s plus 4 out of this term? I'm left with 5s. Cool. What am I left with when I divide s plus 4 out of this one? I'm left with minus 1. You take the common factor and you pull it out and put it in front as the common factor. That's right. So let's check this, because we should be checking all this. And if we check by expanding, so that's going to be s times 5s is 5s squared. This is going to be negative s. This is going to be plus 20s. This is going to be minus 4. So that's going to be 5s squared. Minus 1s plus 20 is plus 19s minus 4. Is that what we started with? It is. So this is our factored version. On a scale of 0 to 5. 0 is, I just want to cuddle up in the fetal position and suck my thumb on the floor because this is disturbing me so badly. And 5 is, this is great, I could teach this to anyone that walks by in the hallway right now. Okay, where are we? I'm seeing a healthy number of fingers, and I don't see anyone hiding under their desk sucking their thumb in a pool of their own saliva. That's good. Okay. Everybody showed me some fingers? Yes? Yes?
Can we try solving these?
Sorry? You should try solving one on your own, yes. Okay. All right. Okay. Do D by decomposition. That's handy. Decomposition. And let's see if you can do this on your own, okay? All right. Okay, take a minute, do this on your own, go. All right, grade 10s. Here's the answer up here that I got, 2c minus 3 times 7c plus 1. The only difference, the only little wrinkle, the little trouble spot you might have run into is like, hey, what is the common factor of 2c minus 3? I don't see a greatest common factor. In this case, notice that the factor over here is 2c minus 3. It's the same. So you can pull out a common factor of 1. It seems like it's cheating, but it's not. When you divide 1 by each of these terms, you get just the same terms back. So 2c minus 3 works to write it as 1 times 2c minus 3. See that? So that's what you have to do in order to get a common factor of 2c minus 3. So here's your answer. That's the one little tricky difference there for D. Let me know if you have any questions.
I have a question.
Yep.
For the quiz tomorrow, do we have calculators or no?
You don't need that.
Do you have calculators for the quiz tomorrow?
You don't need it, Mr. Maxwell. You should say no.
You may have a calculator. Yeah, I mean, yeah, you shouldn't really need it, but I think you can have a calculator.
I mean, some calculators can do polynomial stuff. So I mean,
Yeah, you can't do any fancy stuff though. Yes.
I stop being late. Loosely. No.